2 part C, this is about the metal tungsten, which you can obtain from its ore wolframite, and they've given us the equation, the standard entropies for us to work with here, and they've asked you to calculate the free energy change. So remember that we're dealing with delta G as delta H minus T delta S. We've been given delta H, and so we need to work out delta S. Now the best way to do this is to just put the numbers in under the equations. So WO3, 76. We've got hydrogen was 131, and we're going to need to multiply that by 3. Solid tungsten, 33, and gaseous water, 189, and again we're multiplying that by 3. Now the entropy change is just given by the sum of the entropies of the products, so that's 33 plus 3 times 189. Subtract the sum of the entropies of the starting materials. Now I've put this in brackets here, and that's good practice just to make sure that the calculator can now deal with the signs. And when we work that through, we find out that our entropy is plus 131 joules per Kelvin per mole. So that is useful, but now notice that delta H is in kilojoules per mole, and they want delta G in kilojoules per mole. So we're going to have to turn this into kilojoules per Kelvin per mole. And so when we do that, we're going to get 0.131 kilojoules per Kelvin per mole. So then when we plug that into this first equation here, we're going to get delta G is 115 minus 25 degrees C. To get into Kelvin, we add on 273 degrees plus 25, and we're multiplying that whole lot by 0.131. And when we work that through, we find a value of delta G of 75.962, which is useful to give a 3 significant figure value, which would be 76.0 kilojoules per mole. And it's worth putting that is 3 significant figures here. We get on to the second part of the question. It asks us to calculate the minimum temperature when the reaction becomes feasible. Now the minimum temperature, the reaction is going to be feasible if delta G is greater than 0, and therefore the minimum temperature, this tipping point between feasibility and not, occurs where delta G is equal to 0. So delta G equals 0 at lowest temperature, which I'm going to call TC, critical temperature. And so if we work this through, we've got delta H minus TC delta S is equal to 0, and therefore TC is equal to delta H divided by delta S. Remember, we've got to have delta H and delta S in the same unit for this to work. And for this question, we were told delta H was 115 and delta S was 0.131, keeping both of them in kilojoules per mole units. And when we work that through, we find out that that temperature is going to be 878 Kelvin. Again, a 3 significant figure answer.